Okay, so yesterday, 5A part 1, we did using one sort of angle measurement system. Today, 5A part 2, we're going to do almost a repeat of the same thing, but with the other system. So first, let's do a recap of what am I talking about, that there's two systems for measuring angles in here. What's a system we have for measuring angles? Bearing is our newer one. Okay, so there is a thing called bearing. For the rest of the lesson, as I have an unknown bearing, I'm going to use this little Greek letter B. Looks like a B with like a rat tail growing out of it. So B for bearing for the rest of my bearings. How does bearing work? Where is 0?
At the top.
At the top. Where's 90?
At the side. The right.
The right. And then I'll just keep counting. What's the other system that we've used before for measuring angle? Standard. Position. I'm going to use the letter theta as I talk about those for the rest of the day today. Where is 0 in that world?
To the right.
To the right. Where is 90?
Up.
Up. And then count, count, count. There's a relationship between these two that we could change one of them into the other one if we understand this relationship. So let's try to figure that out. Pick any number from 0 to 360. It's not an axis number.
Or 240.
What do you say?
240.
240. So if I imagine 240 in the bearing world, and I try to reposition myself to that same location, but in standard position world, what would the number over there be?
210.
210. There's a relationship between those numbers that's probably not enough for us to uncover it yet. So pick another number.
7.
7. Let's go bigger than 90 for now, and then we'll double back. I'll use the 7.
97.
97. So if we imagine a 97 in bearing world, imagine being in the same position over there in standard position world. What would the number be? So here lives 97. Over there, imagine same spot. What would the number be?
353.
Agree with 353. There's a relationship that exists every time we play this game, and we're probably not ready to spot it yet. Let's pick another number, but let's do a round number that makes the math easier to spot and do.
170.
170. So in bearing world, here lives 170. If we go to that exact same spot over there, what is the number?
280.
280. Can anybody yet spot a relationship between those numbers?
Don't tell me.
I won't. Let me shoot you a 160. If I go 160,
250. Or wait. 290.
go 290.
Ooh.
What if I went 150?
300.
Go 300.
Is it subtract from 450?
That is correct.
Okay.
The bearing plus the standard position angle can make 450. So if I want to do some algebra, if I want to solve for bearing, I could do, how can I get bearing alone?
450 minus.
450 minus the angle. What if I want to get the theta for the angle alone?
450 minus bearing.
450 minus bearing. And an interesting twist, whichever way you're doing the conversion, to make one of them into the other one, just, you could do 450 minus it. Let's go back to Emily's idea though. She suggested a 7. So if I go 7, we go
83.
83. Different but very similar relationship still exists. Pick another number under 90.
17.
17. If we go 17, we go,
73.
does anybody see it yet?
90.
Yeah, if you add them, if they're bigger angles, they're going to add to 450. If we had smaller angles instead, we'd add to 90. Why is there no real difference? At its heart, why is 90 and 450 really like not that big of a fuss? Where would 450 be if we kept counting? We only counted as far as 360. Where is 450?
At 90.
At 90. 450 and 90, it's two different names for the same spots. So it's also possible 90 minus could work as well as 450 minus. So if I would say to you, one of these is 10, well, you'd want to do 90 minus. The other one is 80. But if I say one of these is 300, then you want to do 450 minus, and the other one's 150. But we can just do a conversion from one to the other if we go 90 minus or 450 minus. Question about that? If you don't like bearing from before, you didn't like yesterday the 5, 6, 7, 8 homework that much, you never have to do it again. We can say, every time they give us a bearing, we can say, no thank you. I'll just go 90 minus or 450 minus, and it's like it never really existed much.
Okay. That's a lot nicer.
So here's a problem that a couple days ago would have been impossible, or bordering on it. It wouldn't have been impossible, but it would have been really a low rate of success probably. Like in physics, we had some problems where I sent you in a crazy direction, and then I sent you in another crazy direction, and the question was, where are we? And the answer was like, I don't know, it's going to take a lot of thinking to figure this out. If they send you in a couple crazy directions, you no longer have to do that. You also no longer have to do anything with bearings. So if they say bearing at 325, you can say, no thanks, I'd rather have a standard position angle, and how do we change out of that?
125.
It'll be 125, do 450 minus. They say bearing at 250, we can say, no thank you,
200.
200. Those were both big enough, we did 450 minuses on them both. Question about those? Then what did we do yesterday? What was yesterday's homework about? Making how did we add those yesterday on 5 and 6 in your homework?
The 20, the cosine and sine.
Yeah, so we go 20,
Sine 125.
probably not first,
Cosine.
probably
125.
cosine 125, and that was called
I.
an I component plus,
20 sine 125 J.
that was the J component. Do the same to this, we can go
7 cosine 200 I. And then 7 sine 200 J.
that was our first move, make the components. Then what?
Add your I's.
Add your I's using your calculator. Or if you're the teacher, your notes, the teeth, and how it goes. You tell me, I'll agree or disagree with you.
Negative 18.
Give me 2 decimal places and I'll agree.
0.5.
I agree with that. And then also,
13.99.
I agree. Anybody puzzle with where we are? We basically did a exchanged at the beginning to get rid of the bearings and just make them angles. And now we're just doing yesterday's problem too. If they asked you for the answer as components, you'd be done. But they usually don't. They usually ask you to find the magnitude and to find the direction. So how do we take this and find magnitudes and directions?
You draw your picture.
Draw a picture. So what would I draw first?
Down 18.05.
Disagree?
Or to the left.
Agree. Before I'd even do that though,
Draw a dot.
I'm going to do a big old dot for my starting point, and then a negative I heads left, and then
Up 13.4.
positive J heads up. Do I write the negative on my triangle sides? No. That dotted thing is called resultant. I want that. And which angle do I always want?
The one touching the dot.
The one touching the dot. So I'm going to get those how?
SAS.
SAS program. Side,
22.84.
I'm showing an 83, but it might be because I kept alive more stuff. So we can live without that for now. On a test, keep alive as many decimal places really as you can, just so we don't get worse off as we go. At, we need to choose wisely our angle. Which angle are you choosing?
The smaller one.
Smaller one in this case, because it's opposite the smaller side, which is showing you,
37.78.
okay. Why did I not write 37.78 as my answer?
Because you're in standing position.
Agree, but there's another reason. There was a note yesterday that I told you people always forget to do.
Oh,
this.
is it the like quadrant 180
Yeah.
minus thing?
Yeah. So since we went left and up, we're in what area on that note?
180.
180 minus what we thought the answer was. What's this world?
180 plus.
180 plus.
360 minus.
This is the world we hope we did enter, but we didn't because
You're good.
you're good. You just leave it alone. If you forget that that note exists, 1 out of 4 problems, you still get lucky and you have the answer. Okay, but for this, we need to make this adjustment. And I'm still not writing that in the answer box. Yesterday, I would have written that in the answer box. If this were yesterday, I'd have been done. Okay, yesterday's process was all the stuff that's inside that space, that's a redo of yesterday. If you did all of that yesterday, you're 100% right, you're gold. But it's not yesterday, it's today. Why is this not my answer today?
Because they want to
Because
be
this whole world yesterday was all standard position world. Today's world is all bearing. We don't like standard, or we don't like bearing world much, I don't think. So we did a trade to go where we're more comfortable, but you have to pay for that still by
going back.
trading back. How do we trade back?
450 minus.
450 minus what we just had, and now I'm writing that answer in the box. So yesterday's world, again, every problem in yesterday's world would have been the same. Make some i's with cosine, make some j's with sine, add them together. That should give you a right triangle to run an SAS program. The side is usually good, but the angle is usually not, and you had to adjust it. That's all we did yesterday. Today we add on a little bit at the beginning to trade away from bearing to get where we were comfortable, but then you have to finish by trading back. Question about that. Homework's in 2 pieces. One piece is on the page where we already lived, and we'll go there and look at your answers from yesterday in a sec. We did a 1 to 6 yesterday. Okay, that same page has a 7 to 10. But then we're also going to do this. One negative about the problems a couple days ago that I don't think you liked or trusted yourselves was you had to think. Some of them we had to think 2 or 3 times and make decisions, and there was no like pattern necessarily to it you could memorize. People seem most years to be a little more comfortable with doing all the problems this way, because even though it's kind of a long process, every problem really is the same. Like, make your trade, do your I's and J's, calculator, program, adjust angle, trade back. It's the same every time. There's not such a thing as a hard one or an easy one. They just are what they are. So this sheet is going to give you practice to just internalize that recipe. Okay, the homework page, the 7 to 10, are all identical in style to this. On the worksheet, 7 through 14 are all identical to this. To save us some bother on 7 to 14, on all of them, the questions are on the left, and these are the answers on the right. I'm just giving you the answers. So you can work the problem until you get the answer. There's no mystery about whether you're getting it right. That's a little frustrating. Probably yesterday you did all this work, and some of them you're like, I hope I'm right. You don't get that. You can get the instant feedback on the odds, but the evens you probably wish you could get that instant feedback too sometimes. Like this paper is going to give you the instant feedback on all of them, whether you're right or wrong. The top 6 is a redo of 2 days back. 2 days back, 1 to 4 was easy, then 5 to 8 was like a little bit iffy. Okay, this 1 to 6 are the 5 to 8 problems redone, and you now have 2 ways you could do these. You could do a thinking way, or you could do a non-thinking, follow the recipe way, and I'll work through an imaginary problem of both ways, and you can decide which you like better. So pick a number.
Any number?
7. Pick a direction, a true direction, north, south, east, west. Pick another number,
11.
and let's pick a bearing, any bearing, let's say that's more than 90. Let's not do one of the lines.
179.
179. Sure, why not?
You're welcome, Marina.
So here's what we did. This is the way we did it before. This will involve thinking. So if you're into a potential thinking way, tune this in. If you hate it, then I'll take you on a path more like the path of the box over yonder. Okay. If we want to do a thinking way, draw a starting point. Let's go 7 to the north first, so I'm going up. I'm going to draw this on here because I may need that later. I'm going to draw this on there because I'm going to need it now. And even though it pleased some of you, I'm going to change this to be a more middle-sized number because 179 is going to go a way that I don't really want it to go. I'll go 139. How would I draw 139 to go to the right spot? Like right now, where does 0 live? Up. This is 90, 98. This would be 180, 270 if it mattered, which it won't. So if I go now 139, I'm headed in here somewhere. I didn't want to go 179 because it would have headed me almost straight down where I started, and that wasn't going to be much of a triangle, so sorry about that. If that's 139, this is where we had to think. So thinking, part 1. we have to figure out one of these angles. Either one would do. They're both findable. I prefer this one because that's where my triangle is going to end up being. But either of them can get us going. Can anybody get either of them? Side picture for clarity. Here's a 90, here's a 180. I'm at 139. How can you find either of those? 180 minus?
139.
139 would get me which one?
The bottom.
The bottom. What if I wanted that one instead?
139.
139 minus 90. So we could either do 139 minus 90, or you could do 180 minus 139. I'm going to do 180 minus 139. I've got a 41 then. Question about thinking item 1. This is a 7. That's an 11. We're no longer thinking, we're in a comfort zone. What would you do at this point?
SAS.
SAS. Run your SAS program, 7, 11, and 41. I'm going to say 7.33. And now I have a minor thing. I want the bigger or smaller angle. Bigger. I always want the starting point angle, and that's opposite the bigger. So the bigger angle I'm seeing is 100. So my picture is actually slightly deceptive. I can't fit 100 in a quadrant. Like that. That's silly. Okay, what I should have probably done here is not drawn my 7 and the 11 to be the same size. Right? The 7, I should have come back here with a bigger 11. We're actually like more down there with the 100. I mean, maybe that's a little bit more real of a picture. Okay, but 100 may or may not be the angle that we want. You have like a 1 out of 8 chance for that angle to be the angle you were after. From this starting point, 0 is north, 90 is that way, and you actually got lucky ducks the way you guys picked this out. Is the angle that you got, this 100.22, it is actually the answer. You sneaky sneaks. Trick me. Let me do a change on this one just so we can do a more realistic problem. Let's go bearing. If I did a bearing at 221, that's going to be a minor tweak. Where would 221 have gone? Bottom left. If this is 221, to figure out where I am, I would do 221 minus 180, and I didn't pick 21 by accident. I picked it so it could get me another 41. And we would have run the same program, and we'd have done the same thing, and we'd have been headed this way. And we act like that never happened. What are the odds you guys would hit the 1 out of 8 chance that it's like the right thing? So here's my 100.22. So this is 0. This is 90. This is 180. This is 270. This could be 360 if you like. We're trying to figure out where we are. And now we've got to think again.
At where what is?
Where is this line pointing? So like, here's my original starting point.
Okay.
This would be 0 or 360. 90 is that way. 180 is down here. 270 is across. What number would I be pointing to if we know the 100? How could you figure it out?
260-ish.
Yeah, how'd you do that?
360 minus the angle.
360 minus the angle would get me 259 and some change. Even aside from the part you guys picked a problem that was weird and then I changed it in the middle, apart from even the change in the middle, I don't think you enjoyed the thinking to get the 41.
Yeah.
And I don't think you enjoyed the thinking at the end to get the angles. It can be done, it's possible, and that's a system that works, but if you're not liking that, let's try plan B. So plan B is think about 7 north in terms of I's and J's. And I'm going to use the 221 version of this. If you do 7 north, what is that in terms of I and J world?
J.
It's a J. A positive J or a negative J?
Positive.
It is a positive J. And if you insisted on doing a number for the I's, it would merely be 0. There is no I part of that. It didn't go that way. This we would say, no thank you. No thank you bearing.
229.
229, how'd you do that?
450 minus
450
229.
minus the I part of this.
I don't know.
11.
Because I.
Yeah. 229. 11 sine 229.
Oh.
Now we'll
Had.
add them up. We're like working the way we were working over there. 11 cosine 229.
Wait, why is the first I 0 again?
It didn't go either of those directions. It just went north.
Okay.
Negative 7.22.
Yeah, I'm going to go 2166 to just keep a little bit more alive for now. The second one, we'd have to actually add the two pieces together, so 7 plus,
Negative 1.3018.
yep. Now,
We draw our picture.
picture, so
Circle.
starting point,
To the left, negative 7 point blah blah blah.
go left,
Down
down,
1 point south.
we always want the length of the hypotenuse, we always want the angle at the
Starting point.
starting point, so
SAS.
SAS. I'm showing 7.33 at. Wisely choose the angle. This is the first time we've had to think on the new scheme.
Smaller angle.
Smaller angle, so you want the
10.23.
10.23. I'm not writing that as the answer for 2 reasons.
Check the coordinate, like the 180 thing.
Yeah, check the note thing. We went left down. So the note for left down into this world is 180 plus. So 180 plus this, I'm now 190, and I'm still not writing that down
Doesn't work the bearing.
because we have to step back into bearing with
459.
450 minus, which is getting 259.77. Same answer either way. We had a little bit of rounding issue on something somewhere by not keeping something alive, but it's basically the same answer twice. You have to pick now, what do you want to do?
The second one.
So that's what you do. Okay, so when you go to do 1 to 6,
Continue.
Okay. So when you go to do 1 to 6 on the paper, pick what you want to do. If you're still working on 5, 6, 7, 8 from 2 days ago homework, that was making people mad. If you still can't do 5, 6, 7, 8 the way we were doing it then, bag that, do this. Okay. What you're gonna have always would be though, if one of the directions is true, north, south, east, west, one of the things with it's gonna be 0 and then that number. You would just have to be a little careful. If you went south, that would be
-0.
-7.
-7.
Oh.
South would go -7. If I go 7 east,
7.
I is +7, J is
0.
0. What if 7 west?
-7.
-7,
0.
0.
I got support from my car.
Okay, so if it's a north, south, east, west, you'd always get that number and a 0, but the number might have to go negative at any time you went, which are the negative directions again? South.
West.
We can cut that, I guess.
Okay.